So in this presentations we are going to discuss about the finite automata in the first unit. So here the finite automata are mechanisms to recognize a set of valid input before carrying out an action. So finite automata are a mathematical model of a systems with the input outputs finite numbers of states and the transition from state to another state with the input symbol sigma. So it gives the transactions from one state to another state. So it's also used to recognize this input string is valid or not if consider any keywords or identifier. So how to recognize this is a keyword, this is an identifier, so that recognitions or the identifications of the particular variable or the symbol by using a transition diagram. So here the step by step identifications is defined by the state by state transactions. So here there are two types of automata, actually NFA and DFA. So NFA is a non-deterministic finite automata and DFA is a deterministic finite automata. So what is the difference between the NFA and DFA? So here both the automata is a transaction diagram for the recognitions of the input string. Okay, so here both are represented by the 5 tuples, that's a set of states, input symbols and transaction function, and the starting state and the acceptance states. But what is the main difference between the NFA and DFA? So in this DFA, each state has a single transition for a single input, but the NFA it has a more transactions for a single input. So in this DFA, each state has a single transition for a single input. If consider if A input is the transfers from one state to another state, so it has only one transactions. More than A can be moved from the more than one states. So this is a difference between the NFA and DFA. So here consider one example, the finite automata of automata diagram and its a transition table. So consider the starting state is a 0, then it has a input A and B. So if when the transactions A is moved to 0 and A, so in the state 0, if it has a input A, it can move the state 1 and 0. So it is an NFA, it is not a DFA. Okay, then this DFA is deterministic finite automata. No state has a epsilon transactions where there is a at most one labeled edge of leaving. Okay, so for the each simple, so here consider the starting state is 0, it has 3 states, starting state is 0 and the ending state is 2. For the input A, it only moved from 0 to 1, only one transaction for the input, but the B is moved 0 to 0, so B have only one target state. So this is an DFA. Actually in this topic very important question, the conversion of the NFA to a DFA. Actually we can convert the NFA to DFA with two methods, so using a Thompson's rules and the direct method. So in this we can convert the DFA from the regular expressions. So the regular expressions is give a statement definitions, so that can be converted into a regular language. Then that regular language, from the regular language we can construct the NFA, then NFA to DFA. So in this conversion is explained by the flow chart, NFA to DFA. So actually the regular expression is initially converted to NFA with the epsilon using a Thompson rule. Then we can determine the DFA, then minimized DFA. By using the minimization method we can minimize the DFA. Finally we get the minimized DFA. From that we can write the regular expression. So it has a circle. Thank you.